reference.
Hey, I hope you didn't record because I was
No, I haven't started recording yet. So I just want to say,
I was talking about kitchen stuff.
Yeah, hi, Jeff. Yeah, hi, dinner here while listening to you.
oh, great. So good evening, everybody, and welcome to a very random RPIrates for March 2021. Hopefully you see the cover slide I'm showing. We're going to talk very informally about simple database access from your R code. And what I'm going to share with you is a couple different examples they're real examples from work that we've been doing over the past 6 months or so, accessing or working with aggregated Wi-Fi data from the RPI campus. Early last summer, the CIO's office set up made a database that they've been using for not much longer than that, for kind of monitoring wireless access point access across the campus, a total of more than 3,000 wireless access points. And it's aggregated data. It counts individual devices and users, but is totally anonymous. And our students developed two different applications, one mostly administrative oriented and one student oriented, that uses that data to kind of figure out the density at different times and different days, different buildings, that sort of thing. And so it's a very interesting problem of accessing this MySQL database that they've got on this system in the CIO's office, which is a kind of a more of the general database access problem that you might see at an organization. But also we face an interesting situation of, if we've got this huge historical gathering of data, say from the beginning of the fall semester to January 1st, or the beginning of the fall semester till now, it becomes very difficult in R to manipulate that. So we want a more database-like way to access even the data that we've kind of modified and persisted. And so there's a way to do that in memory that we just started recently using as we've been modifying the app. So what I'm going to do here is kind of bring up, make sure I got to get my instance of RStudio up here. It was running and then it disappeared. Okay, and I should warn you, if I disappear, it's a temporary thing. I'll just reboot and start again, but hopefully everything will behave itself. Do you see R? Do you see RStudio?
Yes.
Yay, and it's not crashing. Okay, so here's so I've got two examples here. Let's look at this example, this MySQL reader. What this little simple script is doing is it's being triggered by a cron job that's running on a Linux server on the IDEA cluster. And what it's doing every 2 hours, every 2 hours, this script is running and it's going off and retrieving data from this very simple database, this simple but large database that's been set up in the CIO's office. And then it's doing some data preparation that allows a binary version of a R data structure, a data frame, to be loaded in. Okay, and it's there's some stuff that's sort of local to what we're doing. You can see here that we're standard stuff like setting our working directory. And we've been asked by the CIO's office to be good citizens in the sense of don't do humongous queries frequently. So what we have is this idea of we're going to, every 2 hours, we go in and take a sip. I call them sips, where we're going to retrieve, we're only going to retrieve what's been updated since the last time we did a retrieval, which could change. You know, if our session, if our cron job was interrupted or whatever, you know, maybe it's 24 hours, maybe it's longer. So whatever our last read is, we're going to figure that out. You see that there's a data structure here. This last 7 days, this is a data structure that we're working with in the applications. We found that the easiest thing to kind of work with in terms of interaction with these apps which monitor the presence on campus is a kind of a 7-day period. So we have this data structure which holds our last 7 days. And then we also have a historical legacy one, which is the semester data. And right now this semester data is this semester, and this semester I defined as beginning in the beginning. So this is all setup stuff that just kind of help you understand some of the variables we're tossing around. But what we're doing here is we're going to have a very simple SQL query where the beginning time is going to be whenever we last read. The end time of our query is going to be whatever the current time is now. Now we have to have a numerical version of time. So instead of the nice looking system time, which you see down below here, and in the bottom of my console, we need to have a first of all, it has to be Linux time. It has to be time. So sys.time just returns basically a character string. As POSIX CT makes it of type time, and then this number that's going to come back when I execute this is when it decides to do it. This is really weird. Are you still with me, people?
Yes.
Okay, good. I'm not sure why that's not coming back. Hold on. I might have killed my... Oh, sorry. I lost my VPN there for a second. Let's just do this again. Okay, let's look at what we just did there. There we go. So time in the database is represented like you see below here, this numerical representation. And so that's kind of our lingo here in interacting with it. So if we can actually, let's load up some, let's just evaluate these things, get some, so we can have some real values floating around. Okay. And so we can see our start time is this number and our stop time is what we just looked at. Now, here comes the SQL part of things. Okay. So if you've worked with databases before on real systems, you know that you need to make set up some kind of a connection. And R has several packages, database architecture specific packages for connecting easily to databases. There is a general purpose package called DBI, database, I believe it's Database Interconnect, that a number of packages such as R MySQL, R Postgres, et cetera, depend on. And these special packages working in tandem with DBI allow us to establish very easy connections to the databases. So we see right here we're calling, we're using this DB Connect, which is from the DBI package. We're making a MySQL connection, and there's this very interesting parameter here, which is the group, which MyDB, which is essentially the database name. And this is something that took me quite a while to understand exactly what I had to do here, where this MyDB is defined. This MyDB has in it the definition of what our actual connection to that server in the CIO's office is. And the question, where does that sit? It actually sits in your home directory. Okay, so if I, let's look at where, can you see my terminal down below?
Yeah.
Okay, there is a, I'm going to do a more, there is a, the config file that you have to have in your home directory, the user's home directory, which defines the different databases that you're going to be working with. And you see down below here in these square brackets, I've got, and actually I should say, I believe that the correct syntax here, if you look in my folder, you see that there is a .my.cnf and a my.cnf. And I think that the .my.cnf is the actual syntax of the file name. And I think my.cnf is there. I think I put that there, that copy there, in order to be able to find it and remember remember where it is. But I know that in my home directory, this my.cnf and .my.cnf has the same thing. But if we see in here, the address that you have here is, this is the fixed IP address of the machine that that this MySQL database in the CIO's office is set up on. The database has the name postdata. This port, I believe this is a standard port when you're hitting hitting a MySQL database, but as they say, your system administrator would tell you this. And then there's the username and password in the clear that was set up for us to hit this. So all of this information is what gets used when your database connection, when you specify this here and your database connection is being set up. So this connection command is taking this information and expecting to see a MySQL database on the other side. And so we get this. Now, what I should say at this point is, if you've got different databases, you would have the appropriate incantation of that here. So let's say in ITWS they have a Postgres database that everybody hits. You would set up a connection very similar to this line, but you would be using the Postgres version of this function here. You'd be using like the R Postgres, something like that. There also, I should tell you, that there's an Odbc way to do this. Odbc is a kind of a industry standard way to hit databases. It has a higher overhead, and they're in the R community, mostly they use, if they're hitting a MySQL, they use a MySQL. If they're hitting a Postgres, they use Postgres. I actually don't know if there's a special a SQL Server specific R package. It may be that Odbc is used to hit SQL Server, so on a Microsoft type environment. Okay, and what we're going to get to in a little bit is an in-memory way to do this, which is super interesting. Okay, so there's some a couple things that we do to sort of configure this that I got from the tutorial. And then here is the actual query. So what you see here is I'm returning a data frame. So this is just like normal R. Okay, I've got a data frame that's going to be my SIP of data. I'm going to retrieve. I'm going to send off my query to this connection, and here I'm giving it a text string, which is my SQL command. And you can see here that my command is so simple that I'm just defining my command in this query function. It's there's no cleverness here at all, other than specifying whatever my start time and end time is. So you can see here I'm using the standard R paste stuff. Inside the quotes is the stuff that never changes. I've got wide open select because there's not a lot of variables that come back. Okay, so why don't we actually go through and, the other thing I should say is there's some good hygiene here. So we've turned off the warnings, but then we turn it back on, and then we one of the rules in doing DBI, the database connection stuff in R, is always disconnect. So what I'm about to do is I'm about to just do a real quick run of this query. I'm executing. Oh, sorry, I didn't grab I got to go up here. I didn't grab all of my stuff. Okay, boom. Okay, if you look down on my console, you see that db disconnect con comes back true. That's a little signal that everything worked nicely. And now I'm going to show you what it retrieved. Okay, so it just pulled this data frame from the server, and you can see it's pretty simple. There's only 5 columns. There's this sequential record number, which doesn't really mean that much. There is the device name. This is the wireless access point name, and this is the MAC count, which is the number of devices that were connected during the sample interval. And this is the user count, the number of users. And then this is the sample time, not for when we're querying the database, but when that aggregated data was written in. And you can see we can just kind of scan through here during the sample interval. This particular access point in biotech, which is probably the CBIS building, you can see some of the differences here. There were 10 unique devices or unique Macs hitting that during that sample time, but there were only 5 unique users. A unique user is somebody who's logged in with their RPI. They're accessing the network with their RPI credentials. Okay. Sometimes we see that it's the same. Sometimes it's like this building, Jordan, which might be a dorm, and these access points are spread out on campus buildings, off campus RPI buildings. There's several fraternities on here, also all sorts of different things. And we can see that little SIP that I just took brought back almost 3,000 rows of information. Okay, so then the rest of this is just doing some interesting R things. We don't use in our apps, we don't use this data raw. What we try to do is we aggregate this 7 days package together. And I'm actually not going to save these out because I don't want to risk messing up, because this is actually the live script. This is the one that actually gets run with the cron. I don't want to mess up what we're actually persisting. but we can see, some of the kinds of things that you want to do. We've got this sliding window that, so it's a 7-day window that has resolution whenever my last query into the database was. So it's like every 2 hours, say. It's a 7-day window that's sliding forward in 2-hour increments, and I literally lop off the previous piece. And the semester aggregate is, we just slap on, we do a R-bind, we take that SIP of data that we just did and we throw it onto the end of it, and we save it out as R binary so that whatever we need, we can just pull it back in. And one of the things here during the fall, when we were doing the Safe Campus and Study Safe work, we realized that there was metadata that we were working with all the time that we really found was useful. So we did some modifications. We created what we call this semester extended data frame, and one of them is a more human readable date time with a time zone indicated. We never use the record number, so we toss that out. We also find that it's extremely useful to have in our data frame date and day. So in this script, which gets run every 2 hours, we just go ahead and stash that in there, so it's ready to use for any developer that needs to use that. Okay, and so that Wi-Fi semester extended is what we actually save out in the binary, and we save it into this shared directory on the cluster that we're still using, even though it was set up for under our class account, or we're still using it. And this is actually pretty interesting. Also, there's this summary data set that where we're actually doing summary statistics. I believe this is being used by the student, by Study Safe, the Study Safe app, which is a app that uses Wi-Fi data to help students find the potentially safest place to study based on the density of people. It uses a lot of summary statistics. So we see that here. So this is creating these summary columns. Okay. So I'm kind of showing you a couple of things here. I'm showing you this very basic, this database specific stuff, but I'm also showing you this some tricks to make your R coding more efficient. So this is hitting a live database that's on another machine using a connection. Now, let's say you have a semester. Oh, the one last thing. If you're working with somebody, if you're partnering with somebody and they have a database set up, they set up a database for you, they may tell you, well, jump on a server and this is how you'll access it. On the Linux console, if you go in and say MySQL, blah, 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 if you've got your MySQL client running on your Linux machine, it's going to connect to this remote machine using this port, using these credentials. I pasted this in here so I could remember it for when I actually did the configuration of that my.cnf file. So this was a way for me to remember how I actually did it. Okay, so let's hop over to this other piece of code here. It's called the RSQLite Wi-Fi tester. So let's say you've got this really huge data set which you've prepared. One way in R that you can is kind of the standard way of thinking, where you load it in. Either you've got it in CSV form and you read it in and turn it into a data frame, or if you're repeatedly doing this, you would save it out as a binary, an RDS file, so you can directly read it in. No need to parse it again and again and again. But sometimes that's a challenging thing. And then the operations for selecting the subsets of data that you want from that data frame once it's in memory could be a challenge. So Hadley Wickham, the great developer who's given us ggplot2 and who's given us the tidyverse packages, created this package called Sqlite. And what it does is it creates an instance of the Sqlite database in memory, and then you load a data frame into that instance of Sqlite. So this is in your R session, and then you access it using SQL commands. Okay, so what we're doing here is we've got this sample code where I'm using our largest data frame, this RPI Wi-Fi semester extended fall 20 RDS. So this is our historical database, our historical data, all the Wi-Fi hits for the fall 20 term, and I loaded into this script, okay, which is the most the most expensive operation. I then do this. I create this connection object, my Wi-Fi DB, and all I need to tell it here is that I'm doing a SQLite connection. And since SQLite is built to be in memory, I don't have to give it any other connection information. I'm not telling it how to connect to another machine. SQLite is meant to be run locally in memory. So my Wi-Fi DB is my connection object instead of in that other example I showed you. And now I can, I have to do some different things than I did before. I've created this empty, I've got this empty database and I need to write this data into it. So I'm going to use this, this is a DBI command, I'm going to write a table using this connection. So it could have been writing a remote connection if we had a write access to a remote database. I'm using this object, this data frame from above that I read in. And actually, this is the name. I'm sorry, I apologize. This is the name of the table that I'm writing, and this is the name of the object, and I'm calling them the same thing. So, and I could do this as many times as I wanted to do. I could create any number of tables. For this example, I'm just creating the one. So I'm using this connection object. I write it in, and then I can play with it. So let's actually do that here. I'm going to switch over to my console. Is it actually, there it goes. It took, I don't know if you saw the delay in my console. That delay was as it wrote, or as it loaded that there. Okay. So notice down here, I'll run it one more time. Show me the tables that are in the data frame. Show me the tables that are in the database. And now let's actually throw a very simple SQL command at it. And remember, in SQL, we have to tell it, we give it our select. We want to specify the table that we're selecting from. If you want to throw in a where clause, you could. In this first example, I don't have a where clause, but since I'm asking for the whole thing, I want to limit how much. So here are 5 records, the first 5 records from that's extended semester data from that data frame. Okay, and so what it did was it it's doing that select. It's those of you who are familiar with tidyverse, it's similar to doing a wide open tidyverse type, basically filtering and just asking for 5 columns back, and it was very fast. Now we can modify this. Let's actually do something with a where clause. Here I'm asking for I'm again asking for that table that I've specified. I'm giving it a device name that I want to. I'm using it equals, so it's a perfect match. I want just data for this device, and I want it to be day 4, which is the 4th day of the week. Remember that this is our extended data frame. So we have when we wrote this out down here, when we saved, where did we create our extended? Right here. This W day is a magical R function that returns the day of the week that a date is, as long as it's a actual date object. So here, and this is actually a teachable moment here. This is a really cool example of how in a tidyverse pipeline, later in our pipeline, we can use something that we created earlier in our pipeline. So at the start of this, RPI Wi-Fi semester did not have a date column. We have on line 65, we have a date column. And now on line 66, we use that date column we just created to create a date column, which is now when we flip back to this code that we're playing with here, we actually use this in our SQL query, and we're limiting it to 100. And we can do other things. We can sort of mimic where we can query between certain dates. So we'll go, I'll bang that in, boom. Okay, so what I did is I've got this shows you the kind of conversion you need to do. I've got my human version of our date, but this is just a string. I convert it to an actual POSIX date object, date time object. I make it numeric so that I can hit my database with it. I do that for start and end. And then here's my query. And this query is very similar to that query that we used in the other database code, but I'm doing it just for this particular object. Now, what I'm trying to show here is this is it would be pretty expensive to do this. It's expensive to do this interactively against a data frame, but it's relatively inexpensive to do this interactively with your database architecture, even when it's an in-memory one. And that's why we're doing it this way. It's also possible, I should let you know, that there is an extension of the tidyverse called, I believe it's DB dplyr, which lets you slice and dice data from a table using tidyverse commands. So we've often talked about how tidyverse, the syntax is not too different than the pattern matching we do in SQL and SQL. Well, DB dplyr, or maybe it's dbplyr, I can't remember. It's one of those two. Takes that, it takes a tidyverse syntax and it actually reduces it to SQL code and sends it off to whatever your connection is. So I could have done this if I wanted to. I could have done this using tidyverse syntax. But frankly, if I'm hitting a database, I want to think like database. If I'm hitting data frame, I want to think like tidyverse. But that's the thing. So two different examples here, two different ways to skin the cat. I'm curious if people have questions.
I guess my main question is, using this Sqlite is much faster than just doing it with dplyr, you're saying?
Well, it would be for if you've got a massive amount, if you've got like a massive data frame that you want to interactively access. You still have a problem, and so the irony of this is we started using this at the beginning of the term because we wanted to make an interactive version of our Safe Campus app that allowed administrators to kind of analyze arbitrary times and days during the last term. And that was incredibly expensive. Having the entire archive and being able to like seamlessly navigate that archive, it required us to load a huge data frame, and then the resulting filter operations based on interaction was extremely expensive. And so we opted to, what if we use this in-memory approach, in-memory database approach? And that actually worked extremely nicely. It solved the problem, the interaction problem, but unfortunately we overlooked the I was kind of worried about this, is the kind of the way Shiny apps work and stuff like that. There was still a penalty, the initialization penalty to get things set up. So what we're actually investigating now is setting up a MySQL instance on the cluster that will be accessible both by our test apps and the production app. So it's going to be more like the situation we had here. The difference is we'll be hitting this optimized database that's been tuned just for our app. Okay, so the fastest way to do this is, and this is kind of the big point, is when you've got really big data that you need to interactively hit. The most efficient thing for you to do is stand up the right kind of database, and then create your substructures from that, even if it's in this case the manipulated one. Here we didn't. You might ask, well, why don't you just do that with the original one? Number one, we've been asked not to interactively access that original database. Number two, what we actually want to interact with is an extended version of it with additional columns that have more information in it. So we build it out to create this extended form, which is what we've archived. So we've got days of the week and all that kind of stuff. So we've got that, but we still need to be interactive with it. So that's the best approach. And you might ask why MySQL or SQL, why SQL rather than some of the other things. We've done, we did our Twitter work over the last few years. We use Elasticsearch, a humongous Elasticsearch database for that, which is optimized for, we load it in with JavaScript that we get from Twitter. We've also, even before that, we've got a triple store that we access with Sparkle. So semantic web type of stuff. We did a project 4 years ago, 5 years ago, where we had experimental data that we put into a triple store. And hitting it is along these lines, but neither one of those is SQL. So neither one kind of looks like this. Other question, good question. So we have a new person who just joined. Pretext.
Just joined from my class. I send a message to my students.
get in John's WebEx. So Pretext, you just beeped in, right?
Yes.
Okay. Do you have familiarity with database access with SQL, or what I call SQL?
Yeah, I have some. I have done work, but in Python, not in R.
Well, right. Okay, but you probably have seen very similar structures in when you're so here's the one that hits
Ye-
the regular database. You've got to set up.
Yes, I can see some queries. There are some queries written.
Well, there's queries, but before you send off your query, you've got to establish your connection.
Yeah.
However, you do that, and you got to close your connection. You're probably very, very similar in Python.
Most of the thing I can connect.
Yeah, and you've probably you may have also played around with Sqlite, doing a SQL database in memory. Have you ever worked with that?
Yes, like that was in our training at that time only.
Right. So it's just a kind of a convenient thing. I like to say, those of you who are familiar with desktop databases, like on Windows, like something like Access. Now I'm gonna have to wash out my mouth because I actually mentioned Access. Um, SQLite is sort of like Access. It's not meant to be accessed via Odbc or anything. It's just a local database. Um, you can actually do it through. There's a way to stand it up, but it's really not a nice thing. So any other questions? I could. So I'm curious, Andy Winor, are you familiar with SQL and database access and stuff like that?
Well, I really only took a video tutorial on how to use MySQL last
Mhm.
year, so I don't remember much of it.
I've probably reminded you of it.
Yeah, I was like, oh, I know what select is.
Yeah. Well, yeah. I mean, it's a very it's a kind of a fundamental concept. If you think about if you think about tidyverse, what do you do with selects in tidyverse? You select columns, right? So what do you do in a SQL command? What does a select do? A select is selecting your variables. It's selecting your columns. It gets a little bit different when what you also do in tidyverse is then you filter, you select your rows, and that's going to be on your conditions, and so that's where your wheres come in, right? In your where clauses in SQL are your pattern matches, and so you're you're saying, okay, for certain columns like dev name or date time or this or that, I'm setting up my conditions. So the logic in your where is equivalent to those filtering clauses in tidyverse. So it's a direct translation. So it's all about slicing and dicing the data. I'm wondering if I should try to show. Is anybody on the call familiar with Elasticsearch? Because if you are, I'll take a couple minutes and pull up an Elasticsearch query. If not, I won't really bother. But Talanka, you're familiar with SQL, right?
Yeah.
I could try to pull up. If you give me one moment, I'll try to find our CBIS work. Da, 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 da. I don't know if I'll be able to find it here. I meant to have that open. Okay. Oh man, this is going way back. I don't know if I'll be able to. Oh man, I unfortunately I don't think I'm going to be able to. Could it go back that far? No. I promise you, if I find it, it'll be interesting. Some of this stuff I don't know why it's on my machine. You know, oh, maybe I don't know where it is. Sorry about that. I thought we had it in a shared. It was quite a while ago. I could show you. Well, let's go and take a look at the. See if we can pull up our. Oh, that's all the. It's been reworked to do Python analysis. I think it's in here. There we go. Let's see what this is. Oh. Oh yeah, this is. So Elasticsearch, I'm not going to be able to meaningfully go through this with you, but the Elasticsearch is a humongous JavaScript-based or JSON-based database, and basically you can, to access it, you're going to construct a. I'm going to not waste your time on that. So basically, what we do with the Twitter research is that we harvest data from the Twitter API. When that data comes back to us, it's a very large JSON, JavaScript object notation object. And then we directly load that into a very large Elasticsearch database that we maintain on the IDEA cluster. And then we have various different notebooks, R notebooks, and other tools which hit that directly. We use there's one or more Elasticsearch packages in R that access the Elasticsearch databases in different ways. Elasticsearch is got more of a RESTful API, it's more like parameterizing a URL to do your query, similar to Sparkle. Sparkle is exactly the same way. Sparkle is basically when you're accessing a triple store, doing a Sparkle query to a triple store, it's really just about constructing a query string and essentially doing a curl or wget, and that's really what the Sparkle package in R is. It's really just a thin wrapper on R curl, which is a thin wrapper on curl. So you're really just sending a URL to sending a designer URL to a distant point and getting this back and then working with it. So those kind of databases are actually a bit easier in that sense to work with than SQL, because in SQL you have to set up this connection first and then potentially use whatever syntax, but ultimately it's then about constructing the string that you're going to send to your database and getting it back, which is then just a matter of clever coding. Okay, so we're almost up for the hour, so I'll stop sharing here. I'm wondering if there are any other questions.
No, that was great. Thanks, John.
Yeah, and if anybody has any other questions, if something comes to mind later, if you've just got general questions about how do we deal with this big data in R, just let me know and I'm happy to try to figure it out. Okay.
Thank you.
Take care, everybody.
Bye,
Have a
John.
great day. Bye-bye.
Bye.
Stop recording.